Hey guys, and welcome back. Today we're going to be talking about how to solve equations in the form x squared equals p, where p is going to mean just any number really. So we're going to be looking to solve x squared equations. Our learning target today, we're going to solve equation with square roots. When I say with square roots, that's the operation that we're going to be performing on both sides of the equation. To be successful at this, we're going to need to simplify the first perfect squares. Okay, so first we're going to remind ourselves what those first 10 perfect squares are. We made a list in yesterday's lesson, and we're going to talk about how we square root them, what that means as far as being rational. I can solve equations with powers of 2, so we're going to just keep it with a power of 2, meaning that x squared on the title screen. We're going to explain why some equations have 2 answers when we do this. And we're also going to solve real-world applications with this type of equation. So let's take a look at the key idea here. I have a number that is the square of an integer is a perfect square. So I'd like to make another list of our perfect squares. And again, really our perfect squares are all just numbers that are generated by squaring integers. So 1 squared, let's make a list here. Perfect squares. And you can make this list anytime you want just by squaring each number. And you can go beyond the first 10 as well if you're dealing with larger numbers, such as numbers larger than 100. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We can also write on there a couple more if you like. 11 squared is 121, 12 squared is 144. Most of you guys probably know up to 12. If you square 13, you get 169. 14 would be 196. 15 would be 225. I'm going to stop there because I think the largest numbers we're going to have to deal with are in the 100 area. So I think that's a good enough list of perfect squares, though we could keep going. When we talk about squaring, just as a reminder, when we say the words 2 squared or 3 squared, like when we literally say that, that means we're going to raise 2 to the power of 2 or raise 3 to the power of 2. Really, when we say squared, it just means raise to a power of 2 or put an exponent of 2. When we have an exponent of 2, that means we're timesing it by itself 2 times. Okay, so if the power was 3, we would write down 2 times 2 times 2. We would basically write 2 down 3 times, multiplying it. Okay, so right now we're just dealing with squaring numbers, so multiplying them by themselves. So here's that list again of the first 3, I should say, the second, third, and fourth perfect squares. But also keep in mind that when you square a negative number, that's also going to generate 4, 9, and 16 for 2 squared, 3, negative 2 squared, negative 3 squared, and negative 4 squared, and so on. And that's because when you square a negative number, we think about it as a negative times a negative is equal to a positive. So if we think about square rooting something, okay, when I square root 4, really there are 2 answers, because if you think of the number that you could multiply by itself to get to 4, that's both positive 2 and negative 2. Because positive 2 times 2 is 4, and negative 2 times negative 2 is also 4. So that's just a little intro on when we square root something, we have to write 2 different answers, the positive and the negative version. That's why I have these 2 lists here showing the same set of perfect squares. So when we think about our square root, again, just to remind you, it is another number that when multiplied by itself is equal to the original number. Again, our square root symbol looks like a division symbol with a little tail on it. And when we just write the symbol, That means the positive square root of a number unless stated otherwise. So if we're simplifying the square root of 4, that is equal to positive 2 because 2 times 2 is 4. If they say the negative square root of 4, that's going to be negative 2 because you're first going to square root the 4. Let me color code this. Okay, you're going to do this first, square rooting the 4, and then it's kind of like you're multiplying that by negative 1. Okay, it's like there's another little, that invisible 1 sitting next there. So square root of 4 is 2 times negative 1 is negative 2. So if you see a negative symbol on the outside of your square root, your answer will be negative. We're not going to be dealing with if you square root a negative number. That actually is imaginary, okay? And we're not dealing with imaginary numbers. We should never be square rooting a negative number. Squaring a number and taking a square root are inverse operations. That's what my little diagram here is signifying. If you take the number 3 and you square it, you get 9. If you take the number 9 and square it, you get 3. They undo one another, kind of like addition is the inverse of subtraction and multiplication is the inverse of division. So the last little illustration here I have, what does x squared equal 4 mean? It means there's a number that's being multiplied by itself to get to 4. Okay, and we figure that out by saying, well, 2 squared is what equals 4. So if I want to figure out what x is in this equation, I have to think about what do I square to reach 4. Okay, but that could be either negative 2 or positive 2. Negative 2 squared is also equal to 4. Okay, so I could plug negative 2 in for x, or I could plug positive 2 in for x. So what I would like you guys to do, instructions may tell you to separate your answer with a comma. So you can say x is equal to positive 2 or negative 2 like that with a comma. Or you can use the plus or minus symbol. That's this symbol right there. Plus or minus. That means your answer could be the positive or the negative version. You basically just stack the plus symbol on top of the minus symbol. So I'm going to teach you guys now the steps to solving this equation. And really, there's only one step, okay? And remember, we have our order of operations. Please excuse my dear Aunt Sally, okay? Where addition and subtraction are getting undone first when we solve. Remember, when we solve, we go in this direction. Okay, that's first. Then we undo any multiplication or division. And then the E in our PEMDAS is exponent. Okay, so that's going to be done third. Now, in this equation that I've given you, I don't have any addition or subtraction, and I don't have any multiplication or division happening to x. So I can go straight for the squared. So the first step here says to write the equation. So I'm going to rewrite my equation, getting ready to solve. Take the square root of each side. So just like if you had, I'm going to write a little note off to the side here. If I had x plus 2 is equal to 10, you guys would take that x plus 2, you'd scoot over the equal sign, and you'd show me that you need to subtract 2 from each side, because adding 2 and subtracting 2 are inverses of each other and create 0, leaving x all by itself. Then 10 minus 2 is 8. Well, the x is being squared, so we have to undo the square. By doing that, we use a square root symbol, and whatever we do on one side, we have to do to the other. Okay, now when I draw that square root symbol over the x squared, they cancel. Just like if you add 2 and subtract 2. They undo each other, they go away. That's why we cross them out. And I'm just left with x. Now I want to think about what the square root of 100 is. I have to think, what number can I multiply by itself to get to 100, which is both positive 10 and negative 10. Again, We could also rewrite this as plus and minus 10 using our plus minus symbol. We should also check our solution. If we plug back into the original equation, negative 10 squared is equal to 100 because a negative times a negative is a positive and 10 times 10 is 100. 10 squared is also 100. So I know that my answer is correct because when I plugged them in, the equal sign was true. So let's have you guys take a look at the first example. We're going to solve each equation just by square rooting each side of the equation. Okay, now as you can see from all of these equations, A, B, C, and D, all of them, the only thing that is happening to the variable x is that it's being squared. You don't have to undo any subtraction or addition. You don't have to undo any multiplication or division. We will get to that. But right now, all I see is x is being squared. So I have to undo the square. So I'm going to rewrite my equation. Then I'm going to show that I need to square root both sides in order to undo the square. Okay, so again, on the left side, the square and the square root cancel, and you're left with x equals the square root of 4. Now, since you're actually doing the square rooting to both sides of the equation, this isn't just a positive square root symbol like mentioned in the first key concept slide. I'm actually wanting you to find out what x could possibly be, not just the positive version. So we should write that this is plus and minus 2, because negative 2 times negative 2 is positive 4, as well as positive 2 times positive 2. So our answers, plural, there are 2, is positive and negative 2. Let's take a look at B. Again, I'm going to rewrite the equation. Again, I need to undo a square, so I need to square root both sides, making the square and the square root cancel, leaving x all by itself. And then 81 squared is positive and negative 9. Do not forget the plus minus symbol, or if you want to write it out positive 9 and negative 9 like that, that works too. You need to state that there are 2 answers, or you will be incorrect. Okay? You don't want to leave out half of the answer, and half of the answer is the negative number as well. 2 more just to make sure we know what's going on. We got x squared is equal to 49. Again, x is only being squared, so we square root each side, making the square and the root cancel. We're left with x is equal to, what times itself is 49? That's 7 and negative 7, so plus and minus 7. Last one, these actually start going really fast because there's only one step. X squared is equal to 16. Show me square rooting of both sides. Cancel out that square and the root symbol, and we get x is equal to plus and minus 4. Okay, so 4 whole examples we did. Okay, this shouldn't be that hard. You get to your U-try and you should be able to be finished in no time. Okay, let's have you give this a shot. If you're not sure what times itself is equal to 625, I would like you not to grab your calculator, but I would like you to start testing numbers. Again, our perfect squares list, we ended at 12 squared was equal to 144, excuse me. So maybe take a guess at what number, if you multiply by itself, would get to 625 and long multiply it. Please do not reach for your calculator. Again, your test is going to be no calculator, so do not try to do this with your calculator. Practice sharpening up those multiplication skills. Go ahead and give this a try. All right, so in this second example, we're given the exact same thing, only in the equation, we have a fraction. Okay, don't get freaked out, okay, because in that fraction, I want you to notice something. Both 64 and 81 are perfect squares. This is going to make the process easier, okay? And in the order of operations, okay, I'm going to write this down. In the order of operations, you can always distribute the operation that is one step above over the operations below it. So what I mean by that is we have addition and subtraction lumped together, and the next one is multiplication and division. Well, you can distribute multiplication over addition. Okay, this is something that you learned last year in 7th grade, the distributive property. So since there is multiplication between the two and the x plus 2, you can distribute that 2 into the addition, which would give us 2x plus 4. Well, the exponent category is one step above multiplication. You can only ever go distribute one step below. Okay, so multiplication distributes over addition or subtraction. Exponents can distribute over multiplication or division, though they cannot distribute exponents over addition or subtraction. So the reason why I bring this up is in that fraction, all fractions really are just big division problems, okay? This is division. So what we can do is distribute the exponent, which both squares and square roots are considered to be in the exponential category. So in the E category of, please excuse my dear Aunt Sally. So I'm going to do the same process that I had before from example 1. I'm going to rewrite my equation. A squared is equal to 64 over 81. I notice that A is just being squared, so I'm going to square root each side to undo it. Okay, that cancels the squared symbol and the radical, or the root symbol, which leaves me A is equal to, and now I can actually distribute the square root symbol between the two numbers on the numerator and the denominator. So I can say that this is the square root of 64 over the square root of 81. I basically just distributed to both the numerator and the denominator that square root symbol that was over both of them, which makes this problem easier because I know that the square root of 64 is 8, and I also know that the square root of 81 is 9. I also should include my plus or minus symbol, so I'm going to say A is equal to plus or minus 8/9. Leave your answer as a fraction. Give this a try in your second U try. Y squared is equal to 4/9. I want to know what y is. Alright, so in my third example, what I'm doing is I'm having us apply this idea to real life. We have a company makes small custom design stamps that have a square image area. The image area has an area of 1,200 millimeters squared. Okay, so what that means is there is 1,200 little squares that are a millimeter by a millimeter. Okay, so one little tiny millimeter is the length and one little tiny millimeter is the base. Okay, so there is 1,200 of those that fill up this stamp. We want to know what is the exact length of one side of the image area, and if your answer is not a perfect square, approximate your answer to the nearest tenth of a millimeter. Okay, so let's think about what the area of a square is. We actually talked about this in the previous lesson. Okay, area, as we probably remember it, is base times height. Okay, but If the shape is a square, then the base and the height are exactly the same thing. So let's call, instead of this base times height, let's just call it base times base, which is the same thing as saying base squared. Okay, so that really is one of the origins as to why we call a power of 2 square. Okay, because it came from having to do the area of a square, okay, the actual shape of a square. So if we know that the area of this square is 1,200, plug that 1,200 in for A. So again, I'm going to rewrite my square area formula, and this is something you should memorize. Is area equals, and what I'm going to do, instead of using B or H, I'm going to use S for side. Okay, so area is equal to the side squared. Okay, so now I'm going to take what they tell me capital A stands for, which capital A always stands for area. I'm going to plug that 1,200 in for A, since they tell me that's what the area is. That capital A literally means area. So I have 1,200 is equal to the side squared. So really what you're going to be looking out for in these word problems is they're going to tell you that something, an object, is a square. And you need to have this formula memorized because you'll either be plugging in the area in for A, or they might give you a side length and you need to generate the area. So if I'm trying to come up with the side length on this, I have to get S all by itself, which means I have to square root both sides of the equation, getting rid of that square symbol, leaving just the S. So now I have to square root 1,200. And in this situation, I am okay for you to use a calculator because on your test, the numbers aren't going to be this large. Okay, so if you want, you can go ahead and use your calculator, actually type in the square root of 1,200, which I've pulled up my calculator right here. I'm going to type in the radical symbol, which is right here. Okay, again, it looks kind of like that division symbol with a tail. And then I'm going to type in 1,200. And in my calculator, you can end the parentheses or you could leave it open the way that is. Press equals. And there we go. We have 34.6. It says we need to round to the 10th. So if you look to the 100th, the 100th is a 4, which is less than 5. So we just keep the 0.6 a 0.6. So now I'm just going to write that for my answer. 34.6 millimeters. Now for side length, you don't want to put millimeters squared, okay? Because for side lengths, it's literally measuring how many millimeters there are, not square millimeters. We're not counting how many squares are along the side. Area, you're counting how many squares cover a shape. Okay, so I know that the side length of this stamp is 44.6 millimeters. In this case, we do not need to use the plus or minus symbol because in real life situations, sometimes it doesn't make sense to have a negative. Like I'm not going to have a negative side length here for a stamp. But there are going to be some times in life where there are negative numbers. So keep that in mind and apply whether or not you have two answers, the plus and minus version, depending on the situation that they're talking about. So let's have you guys give this a try in your third U try. If you need to, you can draw a picture, but just know they tell you that this painting that you're, looks like you are just trying to find the side length of. Okay, this painting they say is a square. So you're going to use your formula of a square, which is area equals side squared. Go ahead and give this a try. right, so I have one last example for you, and it's just really three different types of equations where we are exercising mixing the different operations, not just seeing a square. So you might see x being squared, but also multiplied, or having something being added to it. So we just need to remember our order of operations. Please excuse my dear Aunt Sally, where when we solve, we go in the opposite direction. So we're going to start by looking for any addition or subtraction. Then we're going to move on and look for any multiplication or division. And then we're going to move and look for any exponents. Okay, so first look for addition or subtraction. Then look for multiplication or division, that's second. And then exponents are third, or for now, last. Okay, if you don't see any addition or subtraction, then look for multiplication or division. If you don't see either of those, then look for the exponents. Let's solve these three problems in that order. Okay, so in this one, when we look at x, I don't see anything being added or subtracted, but I do see a -3 is multiplying the x. So we need to undo that by dividing by -3. Make sure you divide by the negative so that the -3 and the -3 become +1, and you're left over with x squared is equal to. Now, if you can't do this division in your head, I would suggest doing long division. The negatives will cancel, so you can just do a positive division. So 243 divided by 3. 3 does not go into 2, so I'm not going to write anything above the 2. Or you can write a 0, but since this is not going to be a decimal, I'm just not going to write any number. 3 does go into 24, though. 3 goes into 24 8 times. 8 times 3 is 24. If I subtract 24 from 24, so right now I'm ignoring this 3 right here. Okay, I'm ignoring that one. I'm going to do 24 minus 24, which is 0. Then I'm going to drop down that 3. And really, I can ignore the 0 too, because anytime you write a number, like the number 3, there really are an infinite amount of zeros in front of it and an infinite amount of zeros behind the decimal place. We just don't necessarily have to write them. Okay, so I have how many times 3 can go into 3? That would be 1. 1 times 3 is 3. Do the subtraction. Again, we get a remainder of 0, and I have no other numbers that I have in 243. So 243 divided by 3 is 81. So now I need to square root both sides, which will cancel my square and my root, giving me x is equal to, square root of 81 is 9, but make sure you include the plus and minus version. Okay, so again, we've been through solving these types of problems before. We're just adding in that exponent in our order of operations. So let's do this another time in part B. So this time I do see that x has something added to it. So I need to get rid of that first. And whenever we get rid of addition or subtraction, we always just move the equal sign over. So I've got 4x squared plus 5. Move that equal sign over. And since we're adding 5, we need to subtract it to get that 5 to go away. So positive 5 and negative 5 become 0. And I'm left with 4x squared is equal to, and 41 minus 5 is 36. Now I need to look for any addition or subtraction because not addition or subtraction. I need to look for multiplication or division because we just got rid of the addition. And I do see that x is being multiplied by 4. So I'm going to divide that 4 off. 4 divided by 4 is 1, so we're just left with 1x squared. And then 36 divided by 4 is 9. And now I can actually do the undoing of squaring, which is square rooting. So the square symbol and the root symbol will get canceled. We're just left with x. And the square root of 9 is positive and negative 3. Got one more example for you guys, just so that you have a lot of references as you're solving these types of problems. Again, I see no addition or subtraction, so I need to move on and look for multiplication or division. I do see that x is being multiplied by negative 3, so I need to divide the negative 3 off on both sides. Negative 3 divided by negative 3 is positive 1, so we have positive 1x. Positive 1x squared is equal to positive 48 divided by a negative 3. Positive divided by a negative is going to be negative. And then we need to figure out what 48 divided by 3 is. If you don't know, do it off to the side. 48 divided by 3. 3 goes into 4 once. Again, ignore the 8 for now. 4 minus 3 is 1. Then drop down that 8. And 3 goes into 18 6 times. 6 times 3 is 18. 18 minus 18 is 0. I know I'm done. So I have x squared is equal to negative 16. So now I'm left with just x squared, so I need to undo that. Square root both sides. That will cancel the square and the root symbol. And then I have a situation here where in the very beginning of this lesson, I said we are not allowed to square root a negative number. That's a no-no. That's actually going to be something called an imaginary number. Okay, so right now we have no solution for this. Okay, we are not dealing with imaginary numbers. Okay, you're not going to see that situation pop up too many times. Okay, but at the same time, you should be aware that if you make any algebraic errors and you get a negative number that you're square rooting, you've probably done something wrong, okay? You're going to be dealing a lot more with square rooting negative numbers and imaginary numbers when you get to high school, okay? So let's have you give this a try in your last U-Try. You are going to be solving for x. All right, so that wraps up our lesson today. We solved equations that involve square roots. We have our success criteria met. We simplified the first 10 perfect square roots. Okay, that was in example 1, and we also had those kind of showing up in example 2 as well. I can solve equations with powers of 2. Okay, we did that through all the examples. So example 1 through 3, we did that. I can explain why some equations have 2 answers. Okay, we did that from the key concept through example 3. The entire time we talked about how there might be a positive and a negative version. And we also solved real-world applications. That was our third example. All right, so please make sure you ask any questions or get any clarity on any of these examples if you need it. And you can go ahead and start your Google form. Have a great day.